This is video lecture 1 of week 3, and we are continuing our overview of classes which are given to us by Java, like scanner, random, file, and so on, and exceptions are also classes. But what exactly are exceptions? They are a signal that a runtime error has occurred. And this signal is an object that is thrown. It is an indication, and it is thrown by the program to the operating system that I have encountered an error and I do not know what to do. And the operating system will then communicate this to the programmer, and it will, in many cases, it terminates the execution of the program, and it gives an error indicating where this exception has come from and what the runtime error may be. So if something is a class, then an object can be created from that class. So exceptions are objects. And there are two ways in which these exceptions can be created. Either the system creates the exception, so indicated by throw, or the programmer can create the exception. And there are many, many kinds of exceptions. There's an except class called exceptions. And as we go into inheritance later on, you will see that according to the inheritance structure, there are exceptions related to files and arrays and so on. And they have different names, and they are on different places in the hierarchy structure. So let's go and take a look at start with a familiar. So firstly, we need to import, if we import java.io.star, we will get the exception and all of the IO classes. But we can do this individually too. Here we are trying to open a file, and we have been using this. It's familiar, and we use throws file not found exception. Here is an instance of where we put the responsibility on the system to throw the exception, on a method to throw the exception. Here is where the attempt to open a file is being made, and therefore it is the responsibility of the method which is going to open the file to also throw the exception if a runtime error, for example, inability to open the file, or the file is not available to handle. So as you can see, here we say the main program, it throws file not found exception because we're opening a scanner, connecting it to a file. Here's another method that throws the file not found exception. And if we run this program, and there's a file called hello2 does not exist. I'm going to change this to H. And let's see what the exception will look like. And as you can see here, it says exception in thread main, no such file. And here is the file not found exception. And there's a huge chain which tells us, where exactly this exception, which line in our code was causing the exception, right? So I would like to move on to another way of throwing the exception, and that is how can the programmer themselves throw an exception. And in order to do that, we can so the second way in which we can throw an exception is for the programmer himself or herself to throw the exception, right? So this is different from throws, where the method is throwing. This is we are throwing the exception. So there's more control here. And typically this kind of thing, we try to put it in a special structure called a try-catch statement. So let's see what the try-catch. All right, so here is an example of how the programmer can create an exception and throw the exception. Remember that when we say new, we are creating an object. So this is different from throws. This is throw, create a new object, a temporary object from the index out of bounds exception class. So the object is going to be of this type, and this is going to get thrown. When does this get thrown? This code is wrapped inside a try-catch statement. We'll go into a little bit of detail into try-catch with the other examples, but for now, what's happening here is that we are creating an array of size 5 and we're trying to stretch it. What stretch does is that it doubles the size of the array, And then what we're saying is I just purposely set the size of the index to be 16. I know that once I've stretched, this array bigger is going to have a size 10. Index 16 is going to be greater than 10. And if I try to index the number 16, that element does not exist because the arrays of size 10, index 16 doesn't exist. And therefore, I should not try to access an element that is not there, and therefore I should throw an exception. And when I throw the exception, note that there is one part of the try-catch structure which catches this object that I've just created, and it's going to catch it and print exception caught array out of bounds. So let's print this. Let's run this program and see what happens here. So as you can see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We stretched the incoming array, we sorted it, so now it's in ascending order, and then we try to index element 16, which is not there, and therefore the exception was caught. And that was done because we created and threw an exception which was caught in the second part of the try-catch statement. Now let's go a little bit into what is this try-catch structure. And the try-catch structure says that if you want to stop the exception, we can catch it. What does that mean? What is the meaning of stopping the exception? There's one thing that can happen is that involuntarily at runtime, an exception happens and the operating system terminates your program. And it gives the exception number, or it just says exception and it terminates the program. But many times we would like to have a controlled exit. We might want to do some further processing after. It might be a condition that we are purposely trying to take care of and then recover from. In those cases, we have a very powerful feature called try-catch. And what we say here is that we are trying to open a new file. Note that there is no mention of throws or throw at this point. But when we put something into a try structure, then the operating system or the program is aware that there's potentially a runtime exception that can happen. And if this happens automatically, then an exception is thrown. If the file is not found, then an exception is thrown, and that exception gets caught here. If nothing happens, so the sequence is as follows. If nothing happens, I'm just going to go into another slide here and insert a slide. And say, so the try-catch structure is like this. Do something. If error occurs, if exception occurs, create and throw the exception. And this catch block is going to catch. Note that the type of the exception, for example, file not found exception, etc., and a parameter, right? So this is E is an object of type file not found exception. Let me write this a little more clearly. File not found exception. It's all one word. Right? And so what is thrown here gets caught here. And an exception of this type is going to get caught here. If a different exception is thrown and you have not made a provision for it, then that's not going to get caught. So you have to be careful what kind of exception is going to get thrown here, and therefore to catch that exact same kind of exception. You can just say exception here instead of file not found exception, and because exception is more general than file not found exception, it will catch that too. But here's where you can generate an error message. or your own personalized. You can personalize and generate an error message here, right? The big difference between an operating system just throwing an exception and terminating the program and you embedding this in a try catch is that once this catch statement is executed, you can continue, if you wish, with the rest of your processing. So if it's possible for you to continue with processing, you can do that, right? Otherwise, you can choose to exit, but the choice belongs to the programmer. The other thing is that if no exception occurs, then that do something does happen, then that catch statement is not executed, and then you will go straight away and continue with the processing right here. So this is the flow of execution of the try catch statement, that you try. If you're successful, you jump over the catch and continue with the processing. Otherwise, the exception gets thrown and you can catch the exception, generate an error message. If you wish, you can exit the program at this stage, but if you feel that it's not a serious issue, you can continue, fall through here and continue with the processing, right? So that's the sequence that happens. So we have gone over the different ways in which exceptions can be thrown and caught. Let's just go ahead and do some examples right here. We have some of the examples we've covered file not found exception. We also looked at illegal argument exception for, we also looked at array out of bounds exception for the arrays. We can look at some more examples right here. And let's see this one. This one is an arithmetic exception. So what I'm going to do here is I'm going to try to divide by 0. And this one, division by 0, should cause an arithmetic exception. And then because I've given divide by 0, it's going to fall through here, catch the exception, and after that, it's going to say I'm still running the program because as we saw that, the execution is going to continue here. So let's do that. See, they caught the exception, java.lang.arithmetic exception, divide by 0, and I'm still continuing the program. So in a very controlled way, we have done this. I just wanted to point out to you that division, a decimal division, does not give an exception because the 0 is a very, very small number. So this division is not considered to be a division by 0. 0.0 representation is not actual 0, but a very small number. So this is one exception, the arithmetic exception. Let's go to the second one, which is here we've got a null pointer exception. This is a very common one that occurs when we have arrays. As you can see, I've created an array of objects. When you do classes and objects, we see that it's a way for us to have user-defined types. We can create objects. We can also create arrays of objects. And that's what I've done. I've got a class called dog here, and I am creating dogs inside my driver program or client program, and I'm creating an array of dogs. Know that when you do this, not all of the elements inside this array are initialized. All of them are initialized to 0 because we have only created the array. We have not constructed the objects. For this one, for the first one, I'm actually creating a dog, constructing a dog, you see with the new here, and assigning buddy to the 0th element of the array. So only the 0th element of the array has an address. The other elements, right, 1, 2, 3, and 4 are set to null. And therefore, if I try to print the age of the dog by accessing all the elements of the array and calling the dog method, then this one is going to give me an error. And here, let's see if this works as we expect. So here it says exception caught is java.lang.nullPointer exception. So when you print E here, it's actually doing E.toString and printing the exact kind of exception. So I could have even changed this and say null pointer exception, but I chose, like I mentioned earlier, to do exception, and it will catch all kinds of exceptions, including null pointer exceptions. But when you print it, this E will actually specify what was the exact exception right here. So that's null pointer exception for arrays. Let's look at this string example here. What we've got here is an index out of bounds exception. Remember how when we have a string, we have got a string hello there here. I'm trying to take smaller and smaller and smaller pieces of the string till I reach the very end, and then I'm trying to take a piece of the string that's not there. So that's what I'm doing. Position equal to index of t, so I come here, and then I take the substring from here to position plus 2. Position plus 2 will take me t and h, not up until e. Because remember, the substring method needs one more, and it will stop one before. So it's going to stop at h. Then I print that. Then I find the position of e in that substring. Every time I'm saying test is equal to test dot, so I'm just getting a shrinking version of this string. And then here, then I start here, and then I go up to e plus 2, which means I get er. And so the next time it should print er. Then I find the position em. All I'm left with is e. And then let's try to do position plus 1. And then from position, which starts at 0, to position plus 1, which is 1, the substring method is going to only give me e back, and I will not get an exception. So let's run this and see. So I get ERE and E. If I change this to go from position to position plus 2, which means E, and then the next one, and then the following one, but stop one before, then this one will for sure give me, an exception. So here you go. So this one is going to give an exception. So I think we have now covered all the possible exceptions. In fact, let's see, input mismatch exception. There's one more in which if you get a parameter that you're not expecting, that doesn't work, then you can also throw an input mismatch exception. For example, here, in this program, I'm expecting an integer. But let's say the user is expected to enter an integer, but either accidentally or maliciously enters, let's say, a character. So let's see what happens if we are in that situation. So here I enter the number 3, and I don't have an error. Now here, let me run it one more time. And instead of 3, please enter an integer. I'm not going to enter an integer, and it says wrong input, Java input mismatch exception. It has got the exception. You see here, the scanner threw the exception because it was expecting to read an integer, but we gave it a character, and then that exception is caught here, right? So, this is, we can also have, if it's an integer, but it is still less than 0 and we don't want to do factorial of negative numbers, we can ourselves throw. Here the system has taken care of it. We can introduce our own exception and throw an input mismatch exception. So here this is a great example of how we can cover different kinds of input mismatch, leave some to the operating system to throw, and we can take care of the others.